In this video, we will discuss about liquid chromatography mass spectrometry, that is LCMS. So initially, when these technologies are new technologies are invented, they are invented separately. This mass spectrometry is used to identify the compound present in the solution, and liquid chromatography is done to separate the compound based on its functions, such as how polar they are. So when this is an example of retention time. Usually a chromatogram is might look like this, and when LC-MS chromatogram it look like this, whereas if we directly throw the sample in the mass spectrometry, all of them might elute at the near the same time. The reason for this is that because now they don't have anything to separate the sample, separate the compounds present in the sample before they are injecting into the mass spectrometry. So now at this point it is difficult to distinguish which compound is which, and one more thing, that is this kind of samples are not reproducible. This kind of mass spectrometry are difficult to reproduce, because every time we inject the sample based on the time, based on the use, every time the samples chromatogram might look similar, but for different samples, but for same it is then difficult to identify whether this chromatogram is of the same sample or the different sample. So in order to take care of this issue, what people have introduced the column between before the sample is injected into the mass spectrometry. So what column does? Most commonly used column is reverse phase. Reverse phase column. So what done is in this reverse phase, the stationary phase is usually non-polar. Stationary phase is non-polar. And when the sample comes into the column, if it is non-polar in nature, it will bind to the column, and if they are less non-polar, then they will bind later into the column. And how they are eluted from the column into the mass spectrometry, that is done by a mobile phase. Mobile phase is usually a organic solvent. Usually organic solvent. What it does is it changes the polarity of the compounds that sticks to the. It changes the polarity within the column. Now this organic phase is more non-polar, more strong non-polar, or you can say that strong elutant. This organic solvent, what it does is, in case of, suppose, let us understand with the help of example. It is retention time. It actually changes the pH, and this is the pH. Suppose this sample that sticks to the column is acidic and its pKa lies here. pK value lies here. We will understand what is pK value in some other video. And when the organic solvent enters, if its pH is very low, if its pH is very low, what it will does is it will ionize. If its pH is very low, it is now difficult, as acidics are difficult to ionize at low pH. It is difficult to ionize, so it will and non-ionized compound remain in non-polar form. So it will remain in non-polar form, so that it is then difficult to elute, or they will elute in the end, because they have a higher affinity towards the column. Whereas if the this organic solvent has a pH or higher pH, that is 12, then what it will does is it will ionize the compound that is present. Ionize the compound that is present in the, it is attached to the column. So in that case, now ionizable compound is more polar in nature. So now they are polar in nature. Now the affinity between column and the compound is reduced, and then that compound will elute through the column. So if the organic solvent pH is high, then the compounds will elute faster. And we can see the compounds will come here. In case of the pH is high, we can see the compound will come first. If the pH is low, we can see the same compound might come later on. And if the pH is between this pK value plus nearby this pK value, then slight change in the pH will affect the retention time of the compound. The general thumb rule is that our pH of the pH of the mobile phase. This is usually the mobile phase. The pH of the mobile phase should be such. pH of the mobile phase should be plus minus 2 of the pK value of the samples. This I have shown about the acid components, acidic components in the sample, and for the basic component it is completely reversed. That is, this is the pK value and retention time, and this is the pH. So when the compounds are in non-polar form, they will stick to the column, and at low pH, at low pH, these basic compounds are more ionizable than at high pH. So at low pH, when the basic compounds get ionized, now at ionizable form, most of the compounds are non-polar. Most of the compounds are polar. Most of the compounds are polar, so they will not stick to the column, and they will move out to the column faster. So in case of basic, this we will see at low pH. Compounds are elute faster in case of basic, and when the pH is high, at high pH the components or the compounds that are present in the sample will remain in non-ionizable form, and in non-ionizable form, most of the compounds are non-polar. So in that case they will stick to the column and elute later. So this we can see at high pH in case of basic compound. In case of basic, and it is completely reversed in case of when the samples are acidic. So this is some kind of slight introductions in the LCMS when if someone is trying to prepare a method to run their sample. I think this kind of basic information is good and it is essential to understand. Thank you.